So welcome back to Computer Science 3200, Intro to AI. Here we have our schedule, and we can see that today we are going over assignment 1 as sort of a help and tutorial stream. So for those of you looking to learn more about AI in general, you may want to skip this lecture. This is all about the class and assignment 1. So what I'm going to be doing is going over, for those of you, I know a bunch of you have already started asking me questions. A couple of people are finished the assignment already. That's awesome. However, for those of you who got a little bit of a late start or want to know how it works in a little bit more depth, this is the lecture for you. So again, this is being live streamed on Twitch. And if you just at Dave Churchill with any questions you have whatsoever about the assignment, I'll get to those at the appropriate time. And wow, it is like surprisingly sunny out today. It's extremely warm in my room here. That's crazy. It's almost October and we've still got really sunny weather. Okay, so what I wanted to do first is show you, and a lot of the stuff I'm going to be talking about today applies not only to assignment 1, but to all 5 assignments in the class, and for the grad students, the project as well. Because I've kind of got the same setup for all of my assignments, so let's just jump into it, and I'll explain as we go. So the recommended way to go about editing your assignments and stuff. So once you've downloaded it, I'm gonna move this window over so I can have this window and my sort of like files window. So once you've downloaded your assignment, what I'd recommend doing is you can use absolutely any text editor you want or IDE for this course. Anything will work. However, what I'm going to do is I'm going to go over here and I'm going to Google Visual Studio Code because I don't have it installed yet. And let's just go through and install this together, shall we? So let's go download for Windows. For those of you asking in the chat about the Discord is only available to enrolled students, and the info for that is on D2L, which is our university site. So there's no Discord for people who aren't enrolled in the course, unfortunately. So let's download Visual Studio Code, and we'll set that up. So let's just download that here. Okay, that downloaded pretty quick. So let's set that up. Now, like I said, you could even get away with just using Notepad in this course. It's not necessary for you to have a very complicated IDE. I'm just installing Visual Studio Code because it has a couple of nice features that will help us with this course, or help us with JavaScript developing in particular. So here, when we're installing Visual Studio Code, I'm going to create a desktop icon for that. I also want Open with Code actions added to my Windows Explorer file menu context, as well as the Explorer directory context menu. And we'll see what that means in a second. And then we install. And that installation process is pretty similar for Windows, Mac, or Linux. So you can use Visual Studio Code in any operating system, or again, absolutely any editor that you want. Again, Visual Studio Code is it's an IDE, but like there's no compiler or anything in it. It is not the same thing as Visual Studio. So do not install Visual Studio for this course. It's the unfortunately similarly named Visual Studio Code. So I'm not going to launch Visual Studio Code yet. What I'm going to do is I'm going to extract my assignment zip file. So in the assignment zip file, you're going to see that there are a number of files inside the zip file. And we went over this a little bit last time. So in order to look at these files, I'm going to be able to right click now, or at least I should. Yep. And then I can right click in the folder and say open with code. So that will open up the folder in Visual Studio Code. And that's nice because we'll be able to see all the files. The first time I launch it, it's going to take a second. Do you trust all the authors of the files in this folder? Yes, I trust all the authors. There we go. Okay, so I'm going to keep it on a dark theme because if you're using a light theme, I don't know what to do with you. But let's just have a look over here. So I think I can make this stuff bigger. There we go. I'll make it a little bit bigger. Perfect. So now we've got Visual Studio Code open, and I will close the welcome screen, and I have all of my files listed over here. So for example, I've got the HTML file that, is the HTML file that we're going to open to run the JavaScript for the project. I've got a number of JavaScript files here, and I've got an obfuscated solution file, and I've got the student solution file, or the student file where you'll be putting in all of your solutions to the course. So what you're going to do in this course is you don't need any fancy web server. You don't need to run NPM or any stuff like that. All you're going to do is you're going to go to your assignment directory and you're going to launch the HTML file by double-clicking it. Okay, and so it's going to ask me here, oh, how do I want to open that file? I'm just going to open it in Firefox. You can open it in Chrome or whatever browser you want, as long as it's not Edge, right? You could probably do it in Edge, but I'm not going to be teaching. I don't know all the shortcuts and stuff for Edge. So here's your assignment when you open it up. And as I said before, Firefox and Chrome have nice debuggers. So if I hit Control-Shift-K, I have a little debugger over here. Let's see if I can actually dock that to the side. I can't remember how to dock that to the side. Dock to right. Okay, there we go. So I like having my console stuff out here docked to the right. Someone said there's an extension that lets you open it from code if you right-click. Open what from code? Oh, I see. So you could open that. Maybe you could even open it from here, but just double-clicking it from the directory is fine. There's nothing wrong with that. So again, here's our assignment. We've got a nice user interface that we can interact with. If you want complete details on the assignment and what you have to do for the assignment, I recommend going back and watching the end of the previous lecture where we go over all of that stuff. This is going to be more so like how the assignments work in great detail. I'm going to go through the user interface code so that you know that, because if you know that, it might be easier for you to debug your code and just knowing how it works generally is going to make the assignment a little bit easier for you. Okay, something I didn't go over last time, however, is the assignment marks, and I did want to go over that briefly. So here I've got a pretty detailed marking scheme. This is going to be the marking scheme that the TAs are going to use when they're marking the course. So they will open up this text file, they'll open up your assignment, they'll run everything, and they'll see what you did, and they'll give you marks for that. So first of all here, we've got, just the intro. They're going to put your names or whatever. The first section is code style, modularity, and readability. So for me, a big part of programming, especially once you get into your actual job, is code style, code readability, because other people have to actually read your code and look at it and use it. And also the modularity of your code. So you're not duplicating your code unnecessarily. You're using loops when you should. You're using functions when you should. And so 10% of the assignment is worth this. So for example, code has consistent indenting, functions used were appropriate, assignment comments removed. So for example, all these to-do things, you can just remove those. That's fine. Also, we've got data structures. So you want to use a queue for BFS, a stack for DFS. Other functions, so start search properly sets up the search, is legal action works properly, get open and get closed work properly, so that's worth 10% of the assignment. The majority of the marks for the assignment is going to be the BFS pathfinding, okay? So the breadth first search is the important part, because the BFS is where you're going to get the tests for your assignment, and I'll explain that in a bit. So the user interface properly interacts with BFS. Code takes less than 1 second per path. So that's important. I'm putting a depth limit or a time limit on your code, and each of your paths in the test have to run in under a second. So what does that mean? So let me go over here to Solution BFS, and I'm going to click Run Tests. So if I look down here, the solution path has, so this is the test results table. If you hit run tests, what happens with the assignment is that there are a number of hard-coded tests that I found interesting. So I put in manually 20 start positions and end positions. Over here on solution path, that is the cost of the path for each of these That's the cost of the path that your solution found. Or sorry, that the solution found. Over here is your student path. That's the cost that your path found. And so for BFS, because since all of our actions have equal cost, BFS is going to be optimal for this assignment, okay? We talked about optimality and stuff the last time. So when you run the tests, here's the cost, and next to it is a number. And that number is the number of milliseconds it took for your code to run for that path, okay? So if we hit run tests and your code took more than a second, so 1,000 milliseconds per test, then you're going to lose marks because it's too slow. That's a nice benchmark to hit. It shouldn't be very difficult to hit, especially if you're following the code in the lecture slides exactly. And similarly for the random tests, you should get the same results, and you should get not necessarily as fast of times, but times that are still less than a second. So anything less than a second is fine. You don't need to optimize it anymore. Anything more than a second, you're going to lose marks for that. And I'll get back to optimization and stuff in a bit. Oh, and one thing that I didn't mention in the last class is that if no path was found, your path cost should be set to -1. Okay? So if no path was found, it should be -1. And someone asked me, why shouldn't it be 0 if no path was found? Well, it's because if you try and find a path from a given location to itself, that's actually a success, and it will return 0. Okay? So it's -1 if no path was found. So let's go back to the marks. Visual inspection of BFS shows proper behavior. What does that mean? Well, it means the marker is going to do something like this, where they set up a path and they're going to click animated search and then rerun previous path and then maybe set up the speed, right? And we see that your code is actually running something that looks like BFS, where it's going out breadth first and finding the path, okay? And then, of course, for 6980, instead of having 60 marks for BFS, the graduate students are going to have 20 marks for BFS and 40 marks for iterative deepening depth first search. Okay, and the final section here is the depth first search pathfinding. And all you need to have happen for DFS is that the DFS produces a path to the goal. Okay, so if I come up here and I do a BFS from here to here, I'm going to get the optimal path in 4 directions. However, if I look at solution DFS, it's going to be absolutely crazy, okay? And the path is going to look really weird. So DFS, remember, it is not optimal. And so what DFS is actually doing here is that it's going down in the tree all the way to an edge, to a leaf node, and then recursing back. Okay, and that is not an optimal pathfinding strategy. And so the paths that you find are going to be completely different. They are not necessarily going to be the same paths that my code produces. If you hit run tests on DFS, they're pretty much all going to fail because the solution is running BFS. Okay, so the solution runs BFS, and the student path here is running DFS. So DFS is not used for marking whatsoever. As long as you find a path, that's okay. And also, one other thing, I see there's a few questions in the chat. I'm going to answer those in a second. Someone mentioned to me that who has completed the assignment already, that my solution behaves a little bit differently than theirs. Okay, so what does that mean? Let's look at something as an example. So if I go to solution BFS and I run a path, that's normal. However, if I try and find a path from here to here, nothing happens, okay? In my solution, I have many optimizations going on in the background that you will not have for this assignment. Do not worry about that. So the reason my solution if I click try and find a path from here to here, it does nothing. It's because it has other checks in the background that just says, well, first of all, if the start and the goal are not the same color, don't even bother doing a search because we know a path isn't possible, right? So I've done some things behind the scenes, some optimizations, some pre-computations that make my code run a little bit faster. And it also makes it so that, like, for example, when you run your DFS, the coloring of how, like, you see these, like, the yellow, the open list here versus the closed list, it might not look the same for yours, and that's okay. DFS, all it has to do is produce paths. And so that's it for the marking scheme. We are typically pretty easy on the marking. However, for the first few assignments, I do want to see you put a little bit of effort into making sure that you follow the indentation scheme and the coding style that's in the assignment. Okay, so I'm going to go look at some of the questions here. So one of the questions is, for IDDFS, how do we decide max depth? Well, that was covered in the lecture, so I hope you go back and watch that lecture. But I'm not opening the slides again, but essentially for iterative deepening, depth first search, what you're doing is you're setting the initial depth to 1, and then you increase the depth by 1 every time doing depth limited searches to that search. So that was covered in the algorithms lecture. Another question, what is the nodes per second metric when you set a path? Okay, so let's go back and look at that. So if I go to solution BFS, and then I say rerun previous path. Well, let me just, okay, I'll come back here. Solution BFS. Here we go. So nodes per second here is how many nodes I generated in my search divided by the amount of time that it took, the amount of seconds. So here, for example, this BFS from this start to this goal had a cost of 1950. The closed list had 1,401 elements in it. So if I take 1401 and divide it by 0.011 seconds, because it's 11 milliseconds it took it to run, then that's 127,000 nodes per second that it searched, okay? So that's how many nodes were expanded divided by the amount of seconds that it took to run the search. That's what that is. Someone said, I also implemented such tests, won't be a problem for this assignment. So any optimizations that you put into this assignment are fine, but they will not be rewarded with any bonus marks, okay? However, maybe I will say, okay, the top 3 running times in the class for both 3200 and 6980, I will display the names of that, okay? So for example, what we'll do is we'll click run tests a few times, we'll see the total time for each student in the class, and then we'll sort the list and I'll announce the top 3 fastest running solutions during the lecture. So that'll be what you can do. However, please keep in mind that that is not necessary for grades. It doesn't affect your grade, and I will be showing about 10 different optimizations for this assignment in assignment 2. So in assignment 2, we have the same type of pathfinding assignment. However, we're doing the A-star pathfinding algorithm instead of BFS. And when we do the A-star pathfinding algorithm, we're going to do all sorts of other optimizations that we'll get to when I introduce assignment 2. Okay, looking at more questions here. How do we access the PDF slides? What login credentials? That was said in the D2L post. So I can just go back and let me check that right now. So I'm logging in. Just doing this in another window here. COMP3200. Yes. So in the very first announcements item of the year for both 3200 and 6980, if you scroll down, it's the 4th bullet point in the course website /D2L/Discord post. Okay, so it is there. You should just read it a bit more. And please don't post it here because I don't want people outside the course getting access to the slides. Okay, so no more questions for right now, so I'm going to continue on with what I was doing. Okie dokie. So that goes over the marking scheme for the course. And similarly, every assignment in the course will have this marking scheme available. So you will know as soon as you hit this button and then you hit a few random tests, if all of these are green, you're going to be getting like at least 80% in the assignment, right? Because you've gotten everything working up to that point. Okay. If you notice here, whenever I choose a different method here, over on the side, I've got this search constructor time. So that is the amount of time that it took to call the constructor for the search algorithm. So this constructor right here. So if you look at, when you look at solution BFS, the constructor time is 36 milliseconds. So there is a lot of pre-computation going on behind the scenes in order to optimize the running time of this assignment. And that's what we're going to see going forward in this course, that oftentimes when we write AI solutions for things, we're going to be able to pre-compute some stuff. So we can take some time up front to pre-compute some things and store those values so that when we go to run actual paths live, those paths will be faster. Okay, so that's what that search constructor time thing is. Okay, so we can close this, we can close this. Let's go back, and now what I want to do is I just want to go over the license real quick. So again, for those of you who missed my 10-minute rant on academic misconduct, this code in this course is not open source. Okay, it is not open source. As you can see, your information is posted at the top of every file. There are other things hidden in the files that are cryptographic hashes of your student number, etc., etc. So do not let this file end up on a public GitHub or anywhere online or any Russian websites that sell assignments or Chegg or whatever, okay? It'll be a very, very bad time for you if your assignment ends up online. So because I can track you down. So please do not post your solutions online. And if you do end up using GitHub for any purposes like collaborating with your partner, you have to make that a private repo. Okay, so that's out of the way. Now that we've gone over the marks, I just wanted to go over sort of how the user interface works. So in order to explain how the user interface works, and again, you don't need to know this for the assignment, but if you want to interact with the user interface or change it a little bit in order to like help debugging, then it will help to know this going forward in the course. So in the HTML file, the first thing that we do is we import a bunch of JavaScript, okay? So the importing of the JavaScript is just script type equals type JavaScript, and then we have some source files. So that tells the HTML file when it loads, here's all the JavaScript that we're going to be using for this course. I've also got some simple CSS for styling the website. This is like the fonts and stuff like that. Then down here, this is some simple script that I've just defined within the JavaScript itself. And what this does is when the body of the HTML loads, this script is going to run. So here we have a body onload equals init, and this init function up here is just defined within the HTML file rather than give it its own JavaScript file. And that's just going to set up the GUI object, and what it does is it sets up an interval, and then that interval is going to call the GUI's draw function. So this is a pretty standard way of just saying, okay, I'm going to have this class that takes care of all the stuff for me, which is the user interface. And then set interval essentially says, I want to call this update function every this many milliseconds. So if I want this to run at 60 frames per second, then I divide 1,000 milliseconds by 60, and so that's about 16.666 milliseconds or whatever the value is. And so every 16 milliseconds, GUI.draw is called, okay? And the only other thing that I've done here is I have added a container, which is just, or a div, which is called container, and that div is going to be where all of the user interface elements are actually put in. Down here, all I've done is I've put in some text areas that are not displayed, and those text areas just allow me to put in a bunch of the map data. So I could have put the map data in their own JS files or whatever. I just thought this was like a kind of cool little hacky solution to getting the map data in there. And what the map data is if you come here to select the environment map, this is going to be different maps that you can select to run your stuff in. So for example, if I run BFS on this map and I animate it, it actually looks pretty cool because it goes around the map in breadth first search fashion and fills it up in a really cool way. Okay, so that's what the HTML file does. Now you may see here that none of this like drawing of the user interface or any of these buttons or anything like that, none of that is defined in the HTML file. And the reason for that is because I actually like adding things manually via JavaScript. Or I guess dynamically via JavaScript. Because you can see here, like when I load the file, I've got all this text here, but when I click run tests, that text is replaced by a table. Or if I click rerun previous path or do something like that, that's replaced by a different type of table. So in order to more easily dynamically change elements of the UI so you can use them better or more efficiently, instead of defining all of the elements within the HTML file, I have a JavaScript function which actually it constructs all the JavaScript elements and then adds them to the DOM from within the JavaScript. So I'll show that in a second. Okay, so let's look first at this grid GUI function. So you can see, what am I passing into that? Well, I'm passing in the div, so this div container here, and I'm also passing in the value of the default map, which is down here somewhere. So the grid GUI constructor takes in a div and some map data. So let's go over to the grid GUI and we'll see what this does. So here's my grid GUI class, and it's got a constructor, and this extends GUI. Okay, so I've also got a GUI class over here, which has some other things which I'll explain later. But just know that grid GUI extends GUI because GUI has some base functionality that I want all of my user interfaces to have. So the constructor takes in the container, it takes in the map, and then we construct the super, which is the GUI class, or the base class instance with this container. So if we look at what happens at first, if I look at class GUI, what happens in its constructor? Well, I just set the container equal to container because that's where I want to put all my stuff. Now comes all the stuff that's relevant to the assignment. So the user interface is going to store a bunch of things, like it stores this .map, and this .map is a grid of data, which is actually the environment that we're doing our pathfinding in. Next is going to be this is the configuration that's set by the algorithm. So for example, by default, it's just blank, but then I'm going to add the actions, the action costs, and the strategy. So behind the scenes here, this .config object lives in this user interface class. And whenever I do things like change DFS or change to BFS or whatever, that is changing the internal variable of this .config.strategy. So that is then passed into your search whenever you create a new search instance. So that's how that's being done. That's where the options live. I also have a pixel width and a pixel height, and that is just the pixel width and height of this area to be drawn, which is going to be a square. And the square size, which is the square size. Okay, so this is like the different cells in here. So for example, this square size is different from this square size, which is different from this square size. That is just going to be the number of, the pixel width divided by the number of cells, right? So I just take the pixel width and I divide it by the map width, and then that's my thing. Here I'm going to have, this is a number of variables that are specific to drawing things in the user interface. So for example, there's draw info, step. This lets me know whether or not I'm doing single step iterations or I'm doing animations or I'm doing instant paths. This is the animation speed. This is whether or not I show the grid. So for example, up here, if I click toggle grid, I set this.grid equal to false. And if I click it again, I set it equal to true. And then my drawing function is going to use that variable to draw the grid. Down here, this is a bunch of stuff which is relevant to like the current mouse position. So this .mx, that is the current position of my mouse in terms of cell coordinates. Okay, so this .mx is going to be the mouse pause down here in the bottom left that's being drawn. So mx, my here is 7, 1, for example. This .gx, that's the goal X and the goal Y, and that's registered when I second click or when I click and drag. And this .omx and omy, that's the original mouse position and the original mouse, the original mouse position X and Y. So for example, if I click and drag like this, then omx is where I started the click and drag. So this is all just stuff that's relevant to the performance of the user interface. I've got another variable here which stores a reference to itself. I'm not sure why that is. I could probably delete it. Down here, I've got this .colors. So these are hex defined colors. And essentially all that does is over here in the HTML file, where I've defined all of the maps, you see how it's just all 0s, 1s, and 2s? That just defines the colors that are being drawn over here. So for example, I think I have 0 for gray, 1 for green, and 2 for water or something like that. But so if I come back into the grid GUI, and right here, this is RGB. So if I change that to be, so that's the green value. If I add some red to that green, I think I'm going to get some yellow. So now if I refresh, oh geez, what have I done? How did that work? What the hell? What's going on here? Oh, I deleted the hash symbol here. Okay. Okie doke. So yeah, so that changed the green to a yellow. So that's all the coloring is. There's no grass, there's no water. That's just how our eyes interpret things because we're used to video games, right? So that is how we are going to modify that. This .path time, that's just a variable which holds how much time the last path took in order to display that on the thing. So before I get into the draw function, I'm going to look at, and then our constructor calls several functions. The first thing it calls is this .setHTML, and that is like way down here. So this is the setHTML function, and this is the function that actually constructs all of the user interface elements and adds them to the HTML DOM, okay? So here, for example, I have some things like this.createCanvas. So create canvas, if I go over to the user interface, I have a number of helper functions which actually let me very easily construct the user interface elements that I want to add to this page. So for example, if I want to add a button to the page, normally I would like create a button element and I would add stuff to it and set the text and all this kind of stuff. But what I want to be able to do in this function is just say like this.add button with some parameters, right? So what I did was I just created a function called this.add button, and over here we can see that it takes in the container that the button should be added to, the ID that the button should have, the position, width, and height of the button, the label of the button, and a reference to the onClick function that gets called whenever the button is clicked. So for example, here's an add button example. I'm going to say, where is my, oh, there it is. Okay. So this .add button added to the control div. And if I look here, inspector, if I look over here, I think I've got the div. This is the container. And then I've got like, this is my button container, other things. So yeah, this is how the website is split up. So this is saying add to the control div a button called toggle grid. I want that to be at X position 425, and I want it to be at the variable top in the Y position. I want it to be 125 pixels wide, 25 pixels tall. I want it to say on the button toggle grid, and whenever I click that button, I want this function to happen, okay? So the function that I pass in, it just says this.GUI.showGrid is equal to not this.GUI.showGrid, okay? So that toggles the button. Similarly, the rerun previous path button calls this .gui.startSearch. Run tests does some other things. Single step does some other things. Okay, so this is how I'm setting up my user interface. And all of these things are here. So for example, I have a function that lets me really easily construct a text box or a selection box. It lets me add text to the website and give it absolute coordinates. It lets me set up the HTML that's like in the test div that's initially shown, all that sort of thing. So that's what happens when the GUI class is created, is that it sets up the HTML elements programmatically, dynamically through the JavaScript. Could I have done it in the HTML? Yes. Why did I do it this way? I just prefer to do it this way. There's no right or wrong way to do things. Okay. So that's the start search function. Then what happens? Well, next I call add event listeners. So inside add event listeners, you have to add event listeners to elements of your user interface so that when the mouse, for example, goes over those elements, something happens. So what I do here is I add event listeners for mouse down. So mouse down means that this is what happens when the mouse button is clicked, okay? This is what happens when the mouse button is released. And there should be one here. This is what happens when the mouse button is moved. So for example, let's just look at what happens here. Oh, and you have to specify like what interface element you want this event listener to go onto. So I'm going to say this.foreground.add event listener. So this means when the foreground of this map over here, when the mouse goes over it without clicking any buttons, I get the mouse position, then I say new MX. And what that does is the mouse position is returned from the event in raw XY pixel coordinates, but I want to know, say, where to draw this white tile. And in order to know where to draw that white tile, I don't want the pixel coordinates, I want the tile coordinates. So in order to get the tile coordinates from the pixel coordinates, I take the X position of the mouse position, which is in pixel coordinates, and I divide it by the square size. And I do that in the X and Y location. So I say if it's a new mouse position, I'm going to set this up, and if my mouse is currently held down, so if the mouse is not held down, all I do is I draw this square. If the mouse is held down, then I'm going to draw this path and run a search. Okay, so that's how that works. So for example, if you wanted something to happen, let's say we want to print to the console. So if I go over here to the console, again, that's just Control-Shift-K. Whenever I click over here on the map, I want to say print the position of the click on the map. Okay, let's say that's something that you want to do for your debugging purposes. So whenever I click, I want to print the tile that was clicked on. So over here, I look at the foreground event listener, which is mouse down, and I get the position over here. So let's just say, okay, so what's the position? This.GUI, blah, blah, blah. Here we go. So this says if the mouse is already held down, then this is a release, so start the search. Otherwise, if the mouse isn't held down, this is a first click, okay? So we can put it in here, and I can say, if this is the first click, then if I want something to go to the console, I can say console.log this.gui.omx, this.gui.omy. So let's see what happens now. So I'm going to go back and refresh. That's all that needs to happen. And now whenever I click on the user interface, if it's the first click, then it prints out to the console the tile that it was clicked on. Okay, so if you want to add stuff for debugging purposes like that, that's pretty easy to do. And similarly, whenever the mouse is released, it's there. And here is something else that's interesting. So there's an event called onContextMenu. So in your HTML page, whenever you right click, this context menu comes up, and that context menu is different for each browser. However, you can stop the context menu if you want by saying prevent default. So on the foreground, if you right click over on the foreground, okay, then that's not going to do anything. So I've prevented the default context menu so that you can add right click actions to this if you want to. Someone asked, this class will also be uploaded everywhere, right? Yes, so if you type ! Course, then all the information is there. This will go up on the spreadsheet just like normal. So this is just another lecture in the course. Okie doke. So now that we've added the event listeners, we're going to set draw method. So what does that do? Set draw method. Okay, I see. So that just goes through and it reads the visualization method and sets the variables based on if we want instant, animated, or single search. So that's pretty easy. And that just sets the internal variables. So this .draw method equals whatever. Then we draw the background. Okay, so here is a little optimization that I did for these assignments. The environment only changes when we switch the environment, right? So this is only going to change whenever I click this. Now, when I run a search, the only thing the only thing different that gets drawn is the actual path. So the path, the open list, and the closed lists. So the only things new that I'm drawing here are the contents of the open list, the closed list, and if there's a path, then the path. The background stays the same. The environment stays the same. So there's no point for me to redraw the background every frame 60 times per second. In fact, I did that in the first offering of this course, and it was horrendously slow. So what I have here is I actually have a background canvas and a transparent foreground canvas. So let's look at what that does. Let's just refresh this so it's not going. So draw background is a function. Draw background. So what draw background does is it goes through the map array. So this .map is a grid. It's a 2D array. So it's an array of arrays. And it says, hey, this .background context .fill style. So what this essentially does, these two functions set the color to be drawn on the background, and then it draws the color of that tile with the given rectangle. Okay, so one of the very first things that happens when you reload the page is the background gets drawn to the background canvas. So all of these tiles are just drawn once and then never drawn again. And then on top of that, I actually have a foreground canvas where everything initially is transparent. And then as things come up that I need to draw, I will draw them on top of that. Then when we start a new search, I just clear out the foreground canvas. And I'll show how I draw the foreground canvas in a bit. Then what I do is I draw the grid lines. So the grid lines here, if I have toggle grid on, it just draws those lines. So it just draws those lines, really simple. And then I set algorithm, and what that does is it reads the contents of this drop-down menu for your selected item and then sets the item. So if I go to set algorithm, wherever that is defined. So set algorithm, what it does is we get the content, so document.getElementById, set algorithm.value, and then I go through and set the search to the proper algorithm depending on what that was. So that's all that does. And then what happens is 60 times per second, the draw method is called, okay? So this draw method is where where all of the drawing of the foreground stuff happens. And so it's pretty well commented. You can go through and you can look at it. So all I do here is I'm going to I clear out the foreground context every frame. So, well, I don't need the last thing that I drew. So let's just clear out that. So we make it transparent. Then I say, if the left mouse button is down in a valid location, I'm going to draw all of the things that are relevant to the search, okay? So for example, I draw the remaining fringe. So this calls this.getOpen, right? So this is where I draw the open list. Let open equals this.search.getOpen. And then for each thing in get open, I draw an agent, which is just a white tile or a yellow tile. So here, FFCC00, that's yellow. So I draw the tile in the open list. Then I draw the closed list, which is the expanded state. So I call your function, which is this.search.getClosed, and I draw the agent there. Then I draw the path. So if this.search.path.length, so that just says if the path has anything in it, draw all of the things. And then I'm going to draw the agent. It says here in yellow, but the color is actually white. And if the mouse is on the screen, draw the current location of the mouse. And so this is where you see how I'm mousing around down here? That's the current location of the mouse, and it's drawn in white. Over here, if I change this to be red and I go back and refresh, then the current location of the mouse will be in red. So that's how that's done. Okay. If there's a search in progress, draw the goal. If the mouse is on the screen, draw the current location. So, that comment shouldn't be there. So that just means if I've clicked here and clicked here, then I'm also drawing the goal location as well. So if I go to animated search, then I do this. It's just drawing, it's keeping that goal location dot while the search is in progress. Then I calculate how long the drawing took, and I can print that out if I want. But that's basically it. That's how this fairly complicated user interface works. I mean, it's not that complicated. It's just a lot of code because there's a lot of stuff in the interface. So now you should have enough knowledge to be able to like draw to the screen or do whatever you want in order to help you debug your assignments if you want. So the visualization is the first thing for debugging, and then being able to modify the user interface is another thing you can do if you need to for debugging purposes. However, please realize that before you submit your assignment, if you modified any of these JavaScript files in any way, the only file that you are submitting is the search student file, okay? So if you made any user interface changes or any changes to any other files, and that is required for your assignment to work properly, then you can't get marks for your assignment, okay? You've got to make sure that your class search student works with the default user interface as I have given it to you. So don't make modifications to the UI that affect how your solution works, okay? I know probably you weren't going to do that anyway, but I just wanted you to make sure. Okie dokie. So I want to go now to a couple of the questions that I had on Discord. And so let me go set that up real quick. Okay. I've just got to open a couple of things here in order to get that to work. I'm going to close this thing. And feel free to ask any questions in the chat about anything. At this point, from here on, I'm just answering questions. So if you want to talk about AI in general or whatever, or like industry stuff, just let me know and I'll be able to answer questions about that. Okay, here we go. I am getting this up. This is something I spent a lot of time on, so I want to try it. Okay. All right, so I'll go back to that in a second. So inside, this is one of the main questions that I had. Inside search iteration, someone asked me, how do I get the path once I have found a path? Right? How do I get from the current node back to the original node? How do I get all the steps in the path? Well, if we look here, if we go to the node class, each node is going to contain the XY of the state, the action that contained it, and the parent of the node, right? So what we can do up here is when we find a solution, so here, like if goal found, whatever that happens to be for you, we can have a little loop in here. So I could say let node equals current node. Okay, so that node is like the one that we're currently exploring. Now, please don't copy this verbatim. This is just an abstract way of how to do this. So I've got the node that I selected, right? That's part of the algorithm. And then actually let node equals select node somehow, right? So select node somehow is going to be, for example, if you've used BFS, right? So all of this code will be up here in your BFS or your DFS. I just want to move it down here so it's easier to read. So you've got your node. If you were using BFS, then it's going to be like this.open.shift, right? Because this.open.shift is how you get, if you look at these, this.open.shift is going to return the first element of an array simulating a queue, or if you're doing DFS, it's this.open.pop. So however you've gotten your node, you're going to then say like if node.x equals this.gx or whatever I've said, yeah, this.gx, and node.y equals this.gy, right? So if this is the goal, so if node is goal, then what I'm going to do in order to construct the path is I'm going to say let temp equals node. So that temp is a temporary variable that we're going to loop over. And what we're going to say is while temp not equal to null, temp equals node, or temp equals temp.parent. Okay, so what does this do? Well, it does the following. Let me see if this is going to work. Boom. My Blackboard working? Hey, it works. Cool. So in my search tree, how do you like this scene, by the way? I thought it was pretty neat. So in my search tree, I've got a bunch of nodes. Okay, so let me draw some nodes here. So let's say now I've got, here we go. Here's the actions between the nodes. Okie doke. So the question is, how do I get from this node, got to make this bigger again, back to this node, right? So inside each of these nodes, there's a parent pointer, P. Well, it's called parent. What I can do is that this parent pointer points to this node. Its parent pointer points to this node. Its parent pointer points to this node. And this, when you finally get back to the root node, the parent is going to be null. Okay? So what I'm doing is I said, here I'm at a node. So you're going to say, let temp equals node. And then while temp not equal null, and then inside this loop, let me just put the brackets here even though they don't matter. While temp is not equal to null, temp equals temp dot parent. See that how that works? And so here, if this is currently temp, we take temp's parent, and now temp is equal to this one. Is temp equal to null? No, it's not. So we take temp's parent and we go up to this one. Is temp equal to null? No, it's not. We take temp's parent. We go up to here. Is temp equal to null? No, it's not. We take temp's parent. Oh, look, the parent is now null. Okay? Okay, so that is how you get back to that. And then what you want to do is you want to manipulate the path. Okay, so let's go up and look at what we said the path was. The path, if the search found one. If you give me a second, because I can't remember right now. What is the path actually returning? Ah, yes. So that's the actions, okay? So the path is the XY actions in the path. So down here, inside your loop, you can refer to let action equal like the action that returned this is temp.action. Okay, so that's the action that returned it. And then you've got to add that to your path. However, if you notice, this is going to give you this action, then this one, then this one. Oh, geez, I'm not on the blackboard. 1 second. So we're adding to the path. Like, let me just say, we're adding to the path the action. Geez, why isn't it showing me this? Where is the... Okay, here we go. So I took the action. So this is action A, this is action B, this is action C. And so I've added A, B, C to the path. So this is my array. But what I actually want to do is reverse this. So once I have found the path, okay, I'm going to want to add those in reverse order to the path. And so that way, because the path drawer out in the user interface draws the path from the first action to the last action. But if you go backwards through the nodes, you're getting the last action to the first action. So just be aware that you're going to have to reverse that somehow. Now, I'm not going to like do the whole assignment for you. There has to be something that you do on your own. But this is the way that you do that. Okay, this is the method from where you get from the goal node all the way back to the root node. And so you go through it, you get actions, you add actions to a path, and then you reverse the path. So that was the biggest unknown that was sort of left out of last class. Now I saw that there was a few comments up here in the chat, so let me go to that. When you create a new node, what is the action parameter that you need to pass in? Okay, so in the lecture slides, we went over that, but essentially what you're doing when you expand a node is you're going to be iterating. So if I say create all child nodes, so this is the expand function, if you will. So if I go up here to this.config.actions, it's an array of legal XY actions. So in order to generate the legal actions, I'm going to say let, oh, by the way, in JavaScript, so there's like var a equals 10. You can also say let a equals 10. For this course, always, always, always use let. Var has this weird global scoping thing that can really mess up your programs. If you want your variables to behave in like a block safe way that you're used to from other programming languages, use let. Always use let in this course, please. So let a equals 0, a is less than this, .config, .actions.length, a++. So now what we're doing is we're iterating over all of the legal actions, okay? Geez, why isn't this... There we go. So now we can say like let action equal this.config.actions a. So that's the action. So the action is x, y equals the x, y change in position of state by doing this action. All right, so that's what the action actually is. And then when you add actions to the path, you are adding these XY actions. So whenever you construct a new node, you'll say like let child equals node, and this is the new X, the new Y. This is the action that was used to generate that child, and then the original node or the parent goes into the node's constructor. Okay. So that is the answer to that question. When we push a node in the open and closed lists, do we push the node itself or node.x and node.y as a tuple? That's a good question. So open list pushes nodes, closed list pushes states. Okay, we talked about that last time. So inside the open list, your array that you keep for the open list is going to be nodes. And the closed list says, the reason for the closed list is we don't want to re-expand a state of the environment once we have already gotten there, okay? Once we've already expanded it at some other point in the algorithm. So that means that the closed list operates on states, and the open list operates on nodes. So for example, if I've visited, now I'm not going to give an example, but essentially the closed list is states and the open list is nodes. So that's how that works. How do we calculate the G value from the bonus enhancement slide? I don't recommend doing that for this assignment, but the G value is just the sum of all the paths so far, okay? But in order to do that, you would have to put like an extra G here, and then like have a this.g equals G, something like that. I don't please leave that until the next assignment, okay? We're gonna talk about G costs and stuff, so I should not have put that in the slides so early. That was my mistake. And so don't worry about G costs, because that particular enhancement will actually slow you down for this assignment due to the properties of the BFS algorithm. So because BFS doesn't actually use G costs, DFS doesn't use G costs, trying to do anything with G costs is just going to slow you down. So for next year, I'm going to just remove that slide because that's not an actual enhancement for this course. How much should our running time be compared to the solution running time? So obviously you want it to be fast as possible. I suspect that 95+% of the assignments will be far slower than the solution time. And the reason for that isn't because you're bad programmers. It's because the solution to assignment 1 uses the solution to assignment 2. And the solution to assignment 2, as you'll see when we do assignment 2, has a bunch of optimizations that we have not explored yet for assignment 1. Okay, so assignment 2, we'll get into like really cool optimizations that we can do and pre-computations, but assignment 1 does not have those. So if you look at the running time for, if I do like run tests down here, the running time for the solution, the whole thing is done in just a few milliseconds. Okay, and this is running in a virtual machine, so it's even slower. If you get, I said that if you're really interested in benchmarking this, like within a factor of like 5 is fine for assignment 1. But like I said, as long as you are running things in under a second, that's fine. Do not compare your times to the solution time yet for assignment 1. Once we get into assignment 2, then we can really start comparing solution times, okay? So don't spend all your time on Stack Overflow, beating your head against a wall, trying to improve your times for assignment 1, because I'm going to show you all of the optimizations when it comes to assignment 2. Just get all this working, come over here, look at the marking sheet, go through it and say, do I have everything done? That's fine. Don't beat my head against the wall for assignment 1. Assignment 1 is all about getting used to this architecture of user interface and you write the algorithmic backend, because it will be the exact same architecture for every other assignment in the course. Cool. Any other questions? Because I think I have exhausted all the questions and I'm pretty much done with the stuff that I wanted to cover today. So rather than keep you around, why don't I just let you go? And if you have any future questions, feel free to post them in the student-only Discord. Reminding about the is-OOB problem. Oh, you're right. Okay, so over in grid, is-OOB. So this is the function that calculates whether or not a position on the map is out of bounds, meaning its value is less than 0 or greater than width. Inside this function, it has an extra parameter, which is size. Now, that's kind of a typo that I left it in for assignment 1. In assignment 2, we are dealing with differently sized objects, okay? So wherever you might see size, and I think this is the only location of it within the entire assignment, just pass in 1 as the third argument to is-OOB. So you'll be saying this.grid.is-OOB, you might have a particular x and y, and you just say 1 for the final argument to that, because it's of size 1. Okay? So apologies for that. That was an oversight on my part, and that's not your fault. Just pass in 1 to that. Oh, more questions. Good. if the closed list has states, then in getClosed function, we don't need to convert anything. Right. Yes. So that is correct. If you have implemented your closed list as simply an array of states that every time you want to see if something is in the closed list, you iterate over everything in the closed list, then all you have to do is return this dot closed. Okay? So again, in getClosed, if you already have an array of states as your closed list, you would just return this dot closed. That's all you have to do here. Now, if you want to optimize your closed list, which you can, but don't spend too much time on it for assignment 1, because I am going to show you all of the optimizations for the closed list in assignment 2, you may have to do something different. In the open list, you cannot return this dot open. This will break the user interface. The reason it will break the UI is because the UI is expecting an array of states, and if you return this dot open, that is actually a list of nodes. And nodes do contain X and Y states, but the syntax is different, okay? So do not return this dot open for get open. You will have to convert those to a list of states that are contained in the open list. Okay, I'll wait one more minute for more questions, and then I'll take off. While I'm waiting, let me go pop over to the Discord, see if there are any questions. Boom, boom, boom. Nope, no questions in the Discord. And okay, so that was this, kind of a chill lecture where I just want to go over this. And I'm not going to do this for every assignment, because a lot of this stuff like grid GUI, GUI, grid, all that kind of stuff, that is all going to change for the first, that is all going to be the same, for each assignment, the user interface stuff. So we won't be going over like every single file here for future assignments. We'll just be going over the stuff that's specific to the assignment. Okay, I'm getting more questions. This is good. Someone said, I still don't know how to use this dot grid. Okay, so this dot grid contains the data in this grid. Okay, so for example, if I just refresh here and give me a bigger squares. So this is the this dot grid. So if I want to know, for example, in my isLegalAction function, let's say I'm currently at position 10.6. So this is 10.6. You can see it down here in the bottom left. So position 10.6, I'm trying to figure out in my isLegalAction function, can I move up? Well, I need to know, is this square the same color as this square? If it is, then the action is legal. Similarly, is left the same color? Is down the same color? So up, left, and down are all the same color, meaning the grid contains the same value, okay? But if I look, I cannot move to the right because the value of the grid is not the same as the value of the place that I'm trying to go. So let me, let's go back to the blackboard and draw this out in a little bit more of a exact way. So let's say that I've currently got the grid like this, and I've got some lines in the grid. I'm going to do this quick and dirty. MS Paint is awesome. Here we go. So I've got some cells in a grid. Now, I've currently got an XY. Let's say that's right here. Okay, so if this is 0, 1, 2, 3, and 0, 1, 2, so that's 2 in the X direction and 3 in the Y direction. That's my current X and Y. Now, I've got 4 different actions. My actions are up, down, left, and right. So up is going to be 0 in the X direction, -1 in the Y direction. Down is 0 in the X direction and 1 in the Y direction. Left is 1 or -1 in X, 0 in Y, and right is equal to 1 in the X direction and 0 in the Y direction. So let's come down here, and all of my things are the same, but let me color in a few tiles here just so I have something interesting. All right. So let's say we're currently at position 2, 3. So this .grid.get 2, 3 is going to be green. So let's say that's equal to like 0, for example, right? So that's going to have some value. Let's just say that it's 0. Over here, to the right of it, that is going to have a different value. Let's say it's 1. So this right here, I'm going to say, well, my action for here, if I can, my action is going to be right, which is moving 1, 0. So my new state is 2 plus 1, 3 plus 0. So I would say this.grid.get 3, 3 to get the value of that one. So if this.grid.get 3, 3 is not the same as this one, then it's not. Okay. So that's how the grid works, and you use this.grid.get with x and y to get the value of those grid cells. So he says, but how could I know beyond the boundary? For example, the size of the map is 64 by 64. How could I know if sx plus x and sx plus y is less than 64? Well, what you can do over in the code is I've provided that functionality for you. So if I go back over here, so let's say you've got your action. So let action equals, just for example, 1, 0. And you've got your current node. So you're going to say the next x, this is the next x value, is going to be node.x plus action 0. Oops, action 0. Let next y equals node.y plus action 1. So that's how you go from the current node state to the next state. Now you can just say, once you've computed those, if you want to know if nx is out of bounds, you say this.grid.isOOB nx ny. And that will tell you if nx ny is a valid location on the map. Okay? So up here, yeah, so I've got some example code already here, so I didn't need to really go through that. But you create the next x and the next y based on your current x and y and the action, and then you call is this.grid.isOOB. So that's the out of bounds functionality. Someone said, if we don't have to implement IDDFS, can we just remove any mentions of it in the code? This would kind of break the UI if student IDDF is chosen, but we assume that the markers won't select that. Yes. So if you're in the undergrad course, you can remove this. Okay, that's fine. You don't need to worry about that. That's completely okay. Should we make an object based on node class and work on the node object in the whole program? Don't modify node, okay? Just use what's here, use that node class. Don't modify that for this assignment. Just use node and just work with that. You don't need a custom class for that. Yes, so someone just asked, is OOB? This is actually is OOB NX, NY, and 1 because of that little snafu that I made over here with the is OOB that I've already explained. Okay. Now, there's no more questions, but I'll say that I'm going to go, and then that will make people ask more questions, okay? And we're at the time anyway, so what I'm going to do, even if there are more questions posted, I'm going to say post those questions to the Discord channel, to the public Discord channel, and I will happily answer them there. But I'm going to take off, and you should all go enjoy the nice day outside because we're not going to get too many more of them this term. All right, I will see you in the next class, and good luck on your assignment.